So what do we have to do in number 1 to be able to find x? Yeah. Okay. If I do that, you're telling me that this length is the same as that length. But what's the relationship between our mid-segment and our base? We got to double our mid-segment to get to our base. So we get 3x times 2. So if you're going from the base to the mid-segment, we take a half. But if I'm going from the mid-segment towards the base, I got to multiply by 2. Okay, so then that's 6x over there, right? So what's x? 4 is correct. And that's all that one asked you for. It didn't ask you to find length, so you can just stop at x equals 4. Number 2, we have the perpendicular bisector. Every point that's on the perpendicular bisector is what? To the ends of the segment. We made a 90 degree when we bisected, but any point on this perpendicular bisector, no matter what point I pick, is going to be what from the ends of the segment? What do I know about all of these measures? They're the same. So any point on that perpendicular bisector is equidistant from the ends of the segment that got bisected. So W is on the perpendicular bisector, so W has to be the same distance from the ends of the segment. So what do I do with my 2x and my 3x minus 5? W is the same distance from T as it is from Z. Set them equal. Absolutely. How are we going to solve that? What are we going to do? Which will give me a negative 1x equals negative 5. Divide by negative 1. Did anybody subtract the 2x? Okay, if you had subtracted the 2x, what I need you to remember is when you subtract 2x on that left-hand side, what do we get? What's 2x minus 2x? 0. So you've got to make sure that you put the 0 over there if you do the subtract 2, because that ends up making your 5 positive when you add it back to the other side. If you forget to put the 0 over there, a lot of people just kind of interject it into the middle of the x and the negative 5, and then you get a negative 5, which doesn't make sense. So you've got to make sure if you subtract the 2x, because it's the smaller one, to get 0 on that left-hand side. I'm totally fine with whichever way you solve it. I just wanted to make sure if you did it that way, you should put your 0 in. But I'm not done with this problem. Why not? What did it ask me for? Yeah. Absolutely. How do I find the length of TW? You plug in 5 for x. So we get 2 times 5, which is, and we get WZ by taking 3 times 5 minus 5, which is good because you solved for them to be equal, right? So what would happen if you plug that 5 in and you did not get the same answer for both of them? What should you do? Do it again. Go back and look at your work. Go back to the algebra. Go back and plug it in again. Make sure you didn't just type something weird in your calculator. But then if you still didn't get the same answer for TW and WZ, then go back to your algebra and rework it to see where your mistake happened. But you know from the setup that they're supposed to be the same. So if when you plug it in, they're not the same, you got to go back and figure out what went wrong. Remember, on any kind of test, if you plug it in and you get different answers and you can't find your mistake, don't erase the entire problem. Leave the work for me. I will find the mistake. But when I find the mistake, I can just take off 1 point from that mistake, not all of the points because you left me a blank problem. So don't leave things blank on your test. Give me something to grade, even if you know it's wrong. still give me something to grade because I can figure out what went wrong. All right. Then we got number 3. We have an angle bisector in number 3. Angle bisector is ray BG. What do you know about any point on the angle bisector, no matter what point I pick? No matter where I pick, what do we know about them? They're the same. So any point on the angle bisector is equidistant from that angle bisector. So what should we do to this problem? Yeah. You should put AG and GC equal to each other because G is on the angle bisector. Since it's on the angle bisector, we know its distance from the side is the same. Okay, now what? How are we going to solve? All right, subtract 2x from each side. Add 16. It's 12. So x is, okay. Now what do I have to do? Plug it in. All right, so GC, or CG, I guess is the way I wrote it. Doesn't matter which way I do it. Nope, order doesn't matter on segments. We have 4 times 6 minus 16. 8. Okay, then what else do I have to do? So 3 times 6 minus 2, which is? We're going to do some good math here, 16. 3 times 8 is 18 minus 2, 16 there. 8 here. Why do I have to do it twice? All right. We have 2 very congruent triangles here. I have an angle, I have an angle, I have a side. So if BA is 16, BC is also 16. And to double check that we did the math right, 2 times 6 minus 4, what's that get me? 12 minus 4. 8. So we know we got our x correct. So I plugged it into all those places. We put the extra one on BC. What do I need to do with it? Add it all together. Good. Because your perimeter is all of them added up. So what is our perimeter? Which one is it? 48. Because you got 16 times 3. Good? All right. The thing on the ACT is that there's a lot of words in the ACT. Like it becomes almost a reading test. What you need to do is figure out what those words mean. Standard deviation. What does it mean when you deviate? What does that word mean in general? Dividing. Okay, so we've deviated if we divide something. Absolutely. How else can I deviate? What if you're driving and you deviate from your lane? The cop says you deviated from your lane. You went farther away from the center. That's what standard deviation is, going away from the center. So I want to know what the greatest standard deviation, which one of these sets has the biggest amount of difference from the center. Okay, the stats term is its typical deviation from the mean. What's a mean? The middle, the average. Okay, so I want to know which one of these lists has the most difference, like the numbers are the most spread out from our center. Okay, we should be able to kind of eliminate one really quickly. J, the same. They're not going to have the biggest difference from the mean. Could it be F? How much apart are all of these? 1 apart. What about these? Technically 9, but yes, you're going from 1 to 10. So that's further apart than our 1s, right? Okay. Is there another one that we can get rid of? The bottom one. K is also 1 apart. Okay, so now you're looking at, if I look at E and H, think center. Center on E would be about where? 5-ish. What about on H? Okay, are these further away from 5 than these are from 8? So there it is. So deviating, bigger difference from your mean. Does that make sense? Okay, so again, when it becomes a reading test, sometimes you have to take your regular common knowledge of words and kind of say how they would work with math. Deviating from something is change from it. So I want to know the biggest change in my numbers. All right. When you're done, make sure it's 100% correct. Name on it, pass it up. Everybody should have 2 pieces of patty paper. You will need them both today. All right. At the top of your page, it says angle bisectors, and it says trace the triangle in the upper right, or sorry, upper left of the patty paper. So you're going to take your patty paper in the upper left-hand corner, you're going to trace that triangle. Upper left, I believe it says. Upper left of the patty paper. So you're putting that triangle in the upper left. All right, once you got it, it wants you to do angle bisectors. What do we fold to find angle bisectors? What's in half? It's not the shape folded in half. What are we trying to cut in half? I'm finding angle bisectors. We're trying to cut the angles in half. Okay, so if the angle's cut in half, what's going to have to line up on top of each other? The sides, absolutely. So this is the one where you pinch the corner and you kind of roll the paper until the side of the angle end up on each other. Don't do end of segment to end of segment. Pinch the corner and then fold so the sides of your triangle end up on top of each other. So you should have it going through the angle. Then pinch a different corner and get the sides to match up. Doesn't have to be endpoints. It's the sides of the angle. So I want to get this to line up on top of that. I'm pinching on the corner. All right. So on that triangle, you just created angle bisectors. On your test, I'm not going to have you fold patty paper. That would take too long. So you're going to have to draw them into the triangle instead. So if I draw the angle bisector on here, how do I know it's an angle bisector? What marks would I need to see? Yeah. Ooh, but is it perpendicular? It's an angle bisector. So I don't know if I want to mark perpendicular. Okay. You want there and there? Did I bisect the segment? What did I bisect? So how do I mark congruent angles? The arcs, yes. So this, okay, so on your note sheet, where all we did was trace it before, right now you're going to go on that picture, you're going to draw in the angle bisector. Because on your test for this, you have to draw in all three. We're going to draw in the other two as well. What did you notice about all three of those angle bisectors? What did they do? I mean, they all hit they're all making an angle bisector, but did they all hit each other in different spots? They crossed in that middle, absolutely. So they all intersect at one point. Okay, so notice when I was marking it, I've got all three angle bisectors drawn in. I have congruent angle marks on every single pair of angles so that I can tell these two are equal, the two on the right are equal, the two up on top are equal. So again, on your test, when you have to draw me the angle bisectors, you have to put the marks in the picture to show that they're angle bisectors. All right. We're now going to trace the triangle underneath it. You're going to trace the triangle in the lower right-hand corner of your patty paper. And now we're going to do perpendicular bisectors. Okay, we did this last class. How do I get a perpendicular bisector? Folding what in half? Top and bottom. Close. I want to go. We want to fold the what in half? The base. We want to fold this segment in half. How do I know where halfway on the segment is? Fold what to what? Corner to corner. So this one, we're going corner to corner on all three. Corner to corner. Corner to corner on every single one. All right. I think pretty much everybody had this one a little bit easier. End to end's kind of easy, yes? Side to side, folding the sides on top is a little dicier just because it's hard to roll it into that vertex. All right, what do you notice about the perpendicular bisectors? What did they all do? They kind of created an X on the base. They all met in one point, right? Okay, so again, on your test, you're not folding, so we got to mark it. When you do a perpendicular bisector, where does it go through? Where's a bisector go through? The middle. So what you have to do is you find the middle on a side. How do I mark that that's middle? How do I mark that this is in the middle? You fold corner to corner. How do I mark it on the picture? How do I know that that point's in the middle? What would I need to see? The what? Okay, we got to put a line through it. Absolutely. How do I mark that that's going through the middle of the segment? What, like here, middle, I showed arcs. How do I show middle of that segment? Say again. A line. What kind of lines? What do we call those? Starts with a T. Tick marks. We got to put our congruent tick marks in there. Okay, it's a perpendicular bisector. How do I show perpendicular? Straight down the middle at any angle I want. I could go like this. No? What angle? What kind of angle are perpendicular lines? Show me with your arms. Everybody's showing me a T. What kind of angles are those? Those are right angles. So when you draw your perpendicular bisector in here, you got to make it at a right angle. So does a perpendicular bisector need to touch a vertex? Look at what we just drew. Did that touch a vertex? No. So you got to make sure you're paying attention to how you draw them. You got to go through every side, find the halfway, mark that it's halfway, and then do your perpendicular line to it and mark the right angle. Now, what I just drew up here, the way I'm drawing it's not ending up with the point being right on the edge of the triangle. On your patty paper, I believe it does end up right on the base of the triangle. You're freehanding it when you're drawing it in the picture. I'm not looking for 100% perfection because I'm not actually giving you a ruler and making you measure it and all that other stuff. But you got to mark where the tick marks are to show they're congruent, and you got to put the right angle on there. So in both of those situations, they intersected at one point. There's a word for that. It is concurrent. Can I switch off this screen? Okay. Concurrent is when 3 or more lines intersect in one point. That just happened in both those triangles. The point where they meet is called the point of concurrency. So that single point where all 3 of those lines met is called the point of concurrency. The angle bisectors of the side, the perpendicular bisectors of the sides of a triangle are concurrent in a point that is equidistant from the vertices. What is equidistant? Take the word apart. What is equidistant? Equal distance. Okay, so we are equal distance from the vertices. What part of the triangle are the vertices? What are the vertices of a triangle? The what? The angle, absolutely, it's the corners. The angles of the triangle are the vertices. You have a vertex in an angle. So we have that point, and I will show it again momentarily, but this point where they all met is the same distance from all three corners. That is what that statement says. So when I look at that next picture, it's showing you those dotted lines. Here is my point of concurrency. That is called the circumcenter. Point of concurrency. So for the perpendicular bisectors, the point of concurrency, the circumcenter, is an equal distance from the corners. So if you look at the triangle I've drawn there, the dotted lines are the same distance. So if I used that circumcenter as the center of a circle, and I used that equal distance to the corners as my radius, would my circle be drawn inside the triangle or outside the triangle? Say again? Outside, absolutely. So if you put your compass there and opened up from the circumcenter to the vertex and started turning, your circle would end up outside. All the corners would touch the circle, but the circle would be outside the triangle. Yes? All right. The angle bisectors we saw also were concurrent. They're concurrent at a point that's equidistant from the sides. That point's called the incenter. The incenter is the point of concurrency for angle bisectors. So when you look at that picture off to the right, again, the dotted lines are the congruent ones. So going from the incenter to the side, remember we always measure at a perpendicular, these distances are the same. So if I use that as the radius of my circle, where's my circle? Inside the triangle or outside? Inside the triangle, which is what our picture on the next page shows us. So if you turn to that next page, the perpendicular bisectors, the point of concurrency is also the center of a circle circumscribed around the triangle. So where is the circle? Outside. The circumcenter circumscribes the circle. Just puts the circle on the outside because you're going from the center to the corners of your triangle. The point of concurrency for the angle bisectors, the incenter, is the center of a circle inscribed in the triangle. So it is inside. So it's just where can I put that circle? And we're going to work with being able to actually find those points on a triangle. So the first thing you have to decide, is if I want to look for the center of a circle that circumscribes triangle OPS, do I want to look for angle bisectors or perpendicular bisectors if I want to circumscribe the triangle? So where do I want the circle if the triangle is being circumscribed? Side. So do I want the angle bisectors or the perpendicular bisectors to get the circle outside? Look up at the top two pictures. I want the circle on the outside. I want the perpendicular bisectors, right? It's that one on the left. Perpendicular bisectors get my circle outside. Okay, so looking at that picture, are there easy sides to do perpendicular bisectors on? Are there easy sides to go perpendicular to? I'm seeing head shakes and head nods. If you were nodding to me, which ones do you think were easy to go perpendicular to? Which sides are easy? Yes, it's easy to We could turn the paper. Okay, I think we can do it easier. PQ and QS, because what's perpendicular to a vertical line? Horizontal. What's perpendicular to a horizontal line? Vertical. So your easier ones are the vertical and the horizontal. Do I have to do all three? Do I have to handle the third one? What do we know about all three of those lines? Where do they meet? Where do all three perpendicular bisectors meet? In the middle at that point, right? So if I find two of them, will I find that point? Because if two of them meet there, the third one's going there anyways, right? So we just got to do two to be able to find this point that circumscribes it. All right, so I need to perpendicular bisect. We just said perpendicular to a vertical line is a horizontal line. How do I figure out where it bisects? What does it mean to bisect? Create two equal parts. So if I'm looking here at PQ, how would I create two equal parts on that side? Where would I put a dot? At 3. There's my halfway point. It's vertical. What kind of line should I draw to be perpendicular? Horizontal line. Okay, I got that one perpendicularly bisected. I want to do the same thing with QS. Where is the halfway point? 2. It's horizontal. How do I go perpendicular? Vertical. What point is the center of the circle that circumscribes OPS? 2, 3, right here. So when you're doing this, like on the next one, figure out what the two easy sides to do are. I'm always going to give you a vertical and a horizontal. Find halfway, go the opposite direction. So if one's vertical, go horizontal. If it's horizontal, go vertical. Then figure out where those two lines meet. So go ahead and do that one at the bottom of the page. Graph -8, 0. Where is that on the graph? On the X line. Very nice. So you're going left 8 and nowhere up or down to get -8, 0. 0, 6, where do you go? On the Y, you go up 6. So your triangle should end up in which quadrant? What quadrant should your triangle end up in? Negative on the X, positive on the Y. That is the second quadrant. So upper left is your second quadrant. All right, what do we got for a point? I heard -4, 3. I agree. Just to get it up here so that you can see, there is my -8, 0. There's my 6, 0, 6. Here's my 0, 0. So my triangle's in that corner. Halfway, I go this direction. Halfway here, there's my point where they meet, -4, 3. One of the things that happens on your homework is I don't actually have them all be even numbers. You can have a half. So like if my side had been 7 instead of 8, what would have been my X value? 3.5. It's okay to have the decimal, okay? All right, so when we flip to the next page, we have two scenarios happening. You've been asked to place a warehouse so it's an equal distance away from the 3 roads on number 1. You've been asked to place a fire hydrant so it's an equal distance from the 3 locations, so the 3 points on number 2. The very first question you need to answer at your tables is, when we are doing roads, is that looking for angle bisectors or perpendicular bisectors? When we're doing the locations in number 2, is it angle bisectors or perpendicular bisectors? To help you make that choice, I want them at equal distance from the roads versus the corners. Which one would be corners that I'm equal distance from, and which one is the sides that I'm equal distance from? So that's what you're looking to answer at your tables. So check those 2 questions first. Ready, set, go. So you're doing A on both of them. If there's any tracing, anything, I want to have an answer to part A. So if you are tracing right now, I need to come to your desks and figure out if you have the right answers. What do we got for that first one with the sides? I want to fold it so that I can be the same distance from the 3 sides. Is that angle bisectors or perpendicular bisectors? Angle. Because when you look here, I am the same distance from the side of the triangle in all of those spots. In the second one, do I want angle bisectors or perpendicular bisectors if I want to be the same distance from the 3 corners? Perpendicular bisectors. Okay, so now you are taking that second piece of patty paper that you had, and you are going to trace and fold for angle bisectors for the first one and perpendicular bisectors for the second one. You should be able to place them in opposite corners of your patty paper to hopefully be able to do that folding. How many of the angle bisectors and the perpendicular bisectors do you have to do? Yeah. How many do you have to do to figure out where the lines meet? 2. So trace your triangle, fold 2 angle bisectors, fold 2 perpendicular bisectors. found where they meet, you can kind of sketch that on your picture. Second one, you're just folding point to point. All right. What did you find in that first one? Where will our, what are we trying to put up here? A warehouse. It's equal distance from all three. How many angles did you have to bisect? How many angles do I have to bisect to be able to find where the lines intersect? 2. So I could have done these two. Your warehouse should be somewhere-ish. Is it going to be perfect? No, but especially since you're sketching what you folded. Okay, so you had to fold side on top of side to get that one. In the next one, I want to put the fire hydrant equal distance from the 3 corners. So you are folding corner to corner. So if you need the segment to make that happen, you could draw a segment on there. And then I need to find the middle. And I got equal sides. And here's my perpendicular. I can do that same thing with either one of the other 2 sides. Here's my middle. Here's my perpendicular. There's my fire hydrant. So for A, B, and C down the bottom, you were just folding point to point. Because point to point finds the intersection, or I'm sorry, the bisector of that segment. Okay? So again, when you have to decide which one, You decide I want points, then I want perpendicular bisector. If I want sides, I want angle bisector. If I want to be the same distance from the sides, it's angle bisectors. Same distance from the points is perpendicular bisector. Good? All right, we have two more types of lines that are in our triangles. So far we've had angle bisectors and we've had perpendicular bisectors. Angle bisectors are concurrent at the incenter. Perpendicular bisectors are concurrent at the circumcenter. Now we have medians. Median is a segment whose endpoints are a vertex and the midpoint of the opposite side. Okay, well, first of all, how do I find a midpoint? Where is a midpoint? In the middle. What do I mark on my sides to show it's a midpoint? Tick marks. I got to go from the vertex to that midpoint. So I go from that opposite vertex and I connect. I'm going to put one in each for right now just to show you what a median is. And we'll put all three in a triangle. I can pick any side to do a median too. So let's say I pick this side. I again mark where my midpoint is and then connect to the opposite vertex. I could pick the left side. Go halfway, connect to that opposite vertex. So the median just goes from a vertex to the middle of the opposite side. To see middle, we see tick marks. Is that okay? Okay, angle bisector cuts the angle in half. Perpendicular bisector cuts the segment in half at a right angle. Now we have median, cuts the segment in half but connects to the opposite vertex. Perpendicular bisector didn't have to go through a vertex. It just had to cut the side in half at a right angle. This one has to go through the vertex, so I don't care what kind of angle it is. Vertex to the midpoint of the opposite side. The last segment type is the altitude. It's a perpendicular segment from the vertex to the opposite side. You are very used to seeing this because how do you find the area of a triangle? 1/2 what? Come on, area of a triangle. 1/2 or base times height divided by 2. Taking half of something is dividing by 2. So you're used to seeing this as a height. Altitude is just another word for height. The height of a triangle. That altitude could be outside of the triangle. For instance, if I'm dealing with this altitude here, I could put an altitude from any angle. It just has to go from a vertex perpendicular to the opposite side. If I look at that right triangle, going from this vertex perpendicular to the opposite side is already the side of the triangle. So when we use it in the area formula as height, oftentimes it depends on which way the triangle is oriented, which altitude I want. So for instance, on this one, I might go here. But if I did that on the next one, can I end up inside the triangle at a right angle if I'm going from this point? Is there anywhere in here that will give me a right angle? No. So sometimes you have to extend a side so you can put in your altitude. So the altitude can be outside the triangle. The altitude can be outside the triangle. Sometimes it's inside like the first one. Sometimes it's outside like the next one. Sometimes it's the actual side of the triangle, specifically when you have a right triangle. All right, so your median and your altitude also have points of concurrency. So what we're going to do in that next picture is draw the 3 in so you can see how you would have to mark when you have to draw all three in a triangle next week. The three altitudes of a triangle are concurrent at the orthocenter. The orthocenter is your point of concurrency. For an altitude, the only mark I'll need to see is the right angle. So when I look at this first vertex up here at the top, I just have to be able to go straight and make a right angle. I have to be able to do that from the other two vertices as well. So if I go from my bottom left, I'm not going up towards the center, I'm going across to make a right angle. And then I also have to do that from the bottom right, across to make a right angle. This point where they meet is the orthocenter. Okay, so perpendicular bisectors cut through has a right angle and tick marks. They meet at the circumcenter. It's the same distance from the corners. Angle bisector, cut through the angles, so you have arcs in your angles showing they're equal. They're concurrent at the in-center. Their equal distance, that concurrency point, is equal distance from the sides. Altitudes just have that the point where they meet is the orthocenter. There's no extra fact for altitudes. But there is one for where the medians meet. The medians are concurrent at the centroid. The medians are concurrent at the centroid. For medians, it's at the midpoint of the opposite side. So we got to find middle. How do we show middle? We show middle with tick marks. So I find my middle, I connect to the opposite vertex. So find your middle point, you should see tick marks, then connect to the opposite vertex. So if I go to my right side, I find my middle. I mark my two sides are congruent. I connect to my opposite vertex. I find on my left side the middle. I mark my three tick marks to show they're equal. I connect to that opposite vertex. I know this point where they meet is the centroid. And the centroid has a very specific measurement spot. The centroid is 2/3 the distance from the vertex to the midpoint of the opposite side. The centroid is 2/3 the distance from the vertex to the midpoint of the opposite side. And once everybody's had a chance to write that down, I'll kind of give you a visual on what that really means. Okay, so looking at this picture, it is 2/3 the distance from the vertex, here's my vertex, to the centroid. That is 2/3 of this entire thing. So if that's 2/3, what is here? 1/3. Okay, so when we look at the problems on the next page, we're kind of going to look at the entire median as something that can be cut up into 3 equal chunks, because it's 2/3 when I go from the vertex to the median, and it's 1/3 from the centroid, from the vertex to the centroid, and 1/3 from the centroid to that midpoint. So when we go to that next page, we got to figure out, what do I have? Do I have the 1/3 part, or the 2/3 part, or the entire thing? So if I look at this picture and it tells me C is the centroid right here. On this picture, is MC the 1/3 or the 2/3 part of my segment? Beautiful. That means that CD has to be the 1/3 chunk, yes? All right, so in my statement here, it tells me that CD is 1. So this is 1. It's the 1/3 part. What's MC? MC, we said, was the 2/3 part. If the 1/3 part is 1, how would I figure out the 2/3 part? It's 2. Absolutely. You just take the 1/3 times 2. So MC is 2. All right. This one tells me MC is 6. That's the 2/3 part. How am I going to figure out how much the 1/3 part is? Divide it in half. 6 divided by 2 gives me 3, because that's the 1/3 part. You had 2 of them, you only want 1 of them. Does that make sense? Yes or no? Okay. All right, the next one gives me MD. This entire thing is 12. So that's the whole. I want MC. I want the 2/3 part. What do we need to know first? We need to know how much each chunk is, yes? How would I figure that out? 12 divided by 3, very nice, because you have the whole. There's 3/3. We need to break that whole into 3 groups. So how much is one group? So that's 1/3. I want the 2/3. How much? Perfect. Does that make sense? All right, so at the bottom of the page there, you have 3 problems. One where you're doing the circumcenter. So what are we finding? The what of the 2 sides? The middle, but which segments do I have to put in to find that middle? I want the circle that goes around it. You do not want to bisect the angles. You want to do the perpendicular bisectors like you did back on page 2. And then the next 2 are centroid questions. So dealing with the 1/3, 2/3. So go ahead and do those, please. I'll come around and help and get homework passed out at the same time. Those will always be right triangles when I'm asking you to do this perpendicular bisector thing. So if your graph doesn't give you a right triangle, you've graphed something wrong. Still working on those 2 problems. give you answers here in a second. Got answers up there for you to check those 3. Your homework is worksheet 5-2. Remember that you have to decide on those last 2. What's the 1/3? What's the 2/3? Vertex to the centroid. So the one that hits the corner to the centroid, that's always the 2/3 part. Centroid to a side is the 1/3 part.